Hey students, it's time for your Wednesday lesson. And this lesson is going to focus on the quadratic formula. Now, we kind of talked about this a little bit, and this is the reason why we made a little bit of a change as to what we were doing on Monday. Remember, if you remember, if you look at the lesson from Monday, we actually dealt with what we call radicals. Now, the reason we went back and looked at radicals and went away from quadratics is because we're going to be working with this thing called the quadratic formula. Um, you can see it here on your screen. We have the quadratic formula. The formula looks like this. It says for ax squared plus bx plus c. That's just the standard form of a quadratic equal to 0. Very important. It does need to be equal to 0. If it's not equal to 0, this doesn't work. We have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. It seems like a lot. And you know what? It kind of is a little bit of a mouthful, but this is a pretty famous formula. It actually is pretty simple to derive. We're not going to do it today. We don't want to confuse you more than we have to. But let's go ahead and take a look at this a little picture on the right, this graph. Uh, we have three different graphs here. We have a red graph, a blue graph, and a green graph. And the shape of these is called a parabola. Now, we haven't talked about this before, but just like when we graph a linear equation, we create a line. When we graph a quadratic, it makes a specific shape. It's called a parabola, this U shape here. The U can be wide, it can be skinny, it can be flipped upside down, it can be shifted up, down, left, or right. We just showed three here to point out something specific. When you've been solving quadratics, you've probably seen that almost all of them have ended up with two solutions. The solutions always happen when we cross the x-axis. And as you can see here on the green graph, because this one comes down, dips below the x-axis, stops, turns around, and comes back up, we cross the x-axis twice because we end up going down and then right back up. This blue graph comes down and touches the x-axis, just barely touches it, and then turns right back around. So there's one solution in this case versus two solutions in the case of the green parabola. Now, there are certain scenarios where there is no solution. If we move our parabola up, we shift it upwards, like this red graph, it doesn't cross the x-axis at all. And that's a whole different scenario. And they actually had to invent a new type of number called a imaginary number to be able to find the solutions, and I'll put that in quotations, the solutions to that quadratic. Now, we are not going to focus on too much on the graphs. This is just kind of to explain what's going on. Notice here that the solutions in the green graph are not whole numbers. It's negative 2.236 here and positive 2.236 here. Now, although it's been cut off, the solutions here are actually going to be what we call irrational numbers, as in they never terminate and they never end, kind of like pi. We talked about this last week. Whoops. Kind of like pi. Pi is equal to, or approximately, 3.14 dot 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 dot, goes on forever and ever and ever, right? So this is a situation where we wouldn't be able to factor, and we have to use a quadratic formula. So we're going to go review this. Notice here that A, B, and C refer to the coefficients of each term. Every time I see a b in the quadratic formula, it's referring to the linear coefficient, which is this one, the one with just an x to the power of 1 attached to it. If I see a, it's the coefficient of the quadratic term. It's this one right here. It's the one with the variable to the power of 2. And if I see a c, that's just a constant term that's here. And again, it has to be equal to 0 for this quadratic formula to work. So let's go down and look at this problem right here. I've already put it in. I'm not going to do it for you, or I guess I already have. I'm not going to do it live for you. And the reason is this is a pretty simple problem to solve using what we call factoring. Now, what I did is I figured out what times what gives me negative 3, but adds up to 2. The two factors are 3 and negative 1. I factored this quadratic here to turn into this. It's still equal to 0. Now, once it's equal to 0, and we have the two factors multiplied together, we use the zero factor property to separate this into two pieces. Remember, If I have two numbers or two things, two quantities multiplied together, can you hear my son? Ignore him. Two quantities multiplied together and the result is 0, either the first one is 0 or the second one is 0 or maybe even both. So in this case, we just solve this little tiny equation, end up with x equals -3 and x equals 1. Now, the quadratic formula should give us those exact same solutions. It's just in a different way. So what I've done here is I've already set it up for us. I've already identified our A, B, and C. Now remember, it's not A isn't just the one that's in front because this can be organized in a different way. A is always the coefficient of the x squared term, which in this case is going to be 1. Now, what if there's nothing there? What if that's blank? I mean, there's still a 1 there. You have to remember that. So we're going to put 1. Okay, our B term is 2 because that's the linear coefficient, and then our constant term is -3. All right, now I've placed here the quadratic formula so we can refer to it. It's been color-coded. If this is something you want to have available to you while you're doing the homework, I think we already give it to you there. But in any case, we have it here just for reference, and I'm just going to start filling in the pieces. I'm just going to substitute the values in. So I'm going to write x equals, and then minus, even if it's already minus, we're going to put that minus there. And on parentheses, I'm going to put the value of b, which is 2. Okay, and then I have this weird, thing, this symbol here, plus or minus. The quadratic formula actually is two different equations. And to shorthand it, we just write it as negative b plus that junk on the right hand side and negative b minus that junk on the right hand side. And that's how we're going to end up with two solutions. I'll show you how to separate that in a second. Plus or minus the square root of b squared. So in this case, and I'm going to put it in parentheses. So I'm going to write b squared minus 4, and then we got times a, which is 1, and then times c, which is -3, and that's all that is going to be divided by 2 times a, which is 1. Oops, and I put b here. I'm sure you're thinking is like, what the heck is Mr. Montes doing? It's a 2. Okay, let me extend this out a little bit more. There we go. Okay, so now what we're going to do here is we are going to go ahead and start simplifying. And this is part of the reason we did a little bit of the work with the radicals, is because it doesn't always work out to be very nice. In this case it will, and we know it will because we already found the solutions to be -3 and +1. Now, so from all of this work we have right here, we're going to end up with -3 and +1. Kind of crazy, right? So let's just start simplifying step by step. X equals -2 minus 2 is going to be -2 plus or minus the square root of 2 squared means 2 times 2, which is 4. Now, this right-hand piece right here, I'm going to do all at one time. It's -4 times 1, which is -4. -4 times -3 is +12. You are more than welcome to use a calculator on this. We're not gonna, we're not checking up on you, obviously, but use a calculator, make things a little bit more simple for you. You can plug this in exactly how it is. The reason it's positive, is because I have a -4 times a -3, which makes it +12. I'm going to divide by 2 times 1, which is 2. And I'm going to continue on. Following my order of operations, this square root symbol acts as parentheses. 4 plus 12 is going to be 16, by the way. So I have to simplify everything inside that square root first, the radical first, before I do anything outside of it. Now, the square root of 16, now that represents the number. Remember, we're thinking, and I just stuttered a bunch. I'm so sorry. We're thinking about a number. When we square it, we end up with 16. So what is that number? The number is 4, right? So the square root of 16 is 4. So I'm going to keep going here. X equals -2 plus or minus 4 divided by 2. Now at this point, we're actually going to separate into two pieces. We're going to separate this into x equals negative 2 plus 4 divided by 2. And we're going to, or should I say and? It should be and. And x equals negative 2 minus 4 divided by 2. I'm going to highlight this piece, right? Because that is what makes us split this up into two parts, right? And that's where our two solutions are going to come from when we use the quadratic formula. Now I just got to simplify using the order of operations. I got to add the stuff on top first, in the numerator, and then divide by 2. Negative 2 plus 4 is going to be positive 2 divided by 2. So in this case, x equals 1. In this case, negative 2 minus 4 is going to be negative 6 divided by 2. And x equals negative 6 divided by 2 is going to be 3. So we have our two solutions. Do those match up with what we had? Yes, they do. So you have a second way of doing this one. Now, if you notice, the work for factoring is way, way less than the work is going to be for the quadratic formula. Look at how much we have to do as I zoom out, right? So I guess the question would be is, Mister, why would I ever have to use this? Why can't I always factor? Well, it turns out that there's some types of quadratics that are not factorable. And we're actually going to show you an example of that here, right? So this was just to show you that we end up with the same solutions, basically. So let's look at a different quadratic. Let's look at, and we're going to put solve, and we have negative x squared minus 8x plus 2 equal to 0. So a couple of things to check. Are we equal to 0? Yes, we are. It is a quadratic, so we're going to use the quadratic formula. Oh, you know what? And I think I have it already saved. Let's see. Copy, paste. All right. Look at that. Let me put that right there. So, first things first. We're going to identify A, B, and C. Oh, you know what? We should really talk about why this is not factorable, right? Suppose we did do this. And remember, this is A times C, and this is B. A here is negative 1. So it's negative 1 times 2 is negative 2. But adds up to negative 8. So this is where we get stuck. What two factors multiplied to negative 2, so two numbers, but add up to negative 8? There isn't any. The factors of negative 2 are, it's either 1 times 2, negative 1 times 2, or it's positive 1 times negative 2. In both cases, we get negative 2. There's nothing else I can do to get to multiply to 2, but I need to add up to negative 8. So this is impossible. So this actually doesn't factor using whole numbers. So what we're going to do is we're going to go ahead and we are going to use the quadratic formula because that's our only option at this point. So this doesn't work. So let's get rid of this because that's trash. All right. So first things first, identify A, B, and C. Now I'm going to come up here. Remember A, which is going to be in blue, is the coefficient of the quadratic term. B, which is going to be in red, is the coefficient of the linear term, which is negative 8. Notice that the negative is red also. We have to take into consideration the sign. And then the constant term is positive 2. So we have our A, B, and C now. We got A, C is in, scroll down just a little bit. There we go. So we got C, which is equal to positive 2. We got B, which is equal to negative 8. And we got our A, which is equal to negative 1. So I'm just going to substitute the values in just like I did before. So I got x equals negative b, so that's going to be, we need the negative. That stays, that always stays. Everything in black here has to be there. Now in parentheses, I'm going to put in b. I'm not going to just put in the 8, I'm going to put in a negative 8. And what that's going to do is eventually when we start simplifying, this will turn into a positive. So we got minus b plus or minus the square root of b squared. B squared is negative 8, so that's negative 8 minus 4 times, and we have two pieces. A is going to be negative 1, and B, or C, is going to be positive 2, and that's all going to be divided by 2 times A. 2 times negative 1. It is really hard to keep track of all the colors, but it's important and necessary, right? So we can keep track of it in our brain. It's called color chunking. If you ever become teachers, that'll be a term used widely in your trainings. Okay, so now minus negative 8 is going to be positive 8. So I'm just going to write 8. Plus or minus, and again, now we're just simplifying, right? This already represents the solutions. We're just simplifying. Plus or minus negative 8 squared. So that's negative 8 times negative 8, a positive because we have a negative times a negative. 8 times 8 is 64. Now, I have a negative, and that little square screen keeps popping up. Get rid of that. A minus 4 times a negative 1, which is positive 4, times 2 is going to be 8. So it's going to be plus 8 divided by 2 times negative 1 is negative 2. Keep going. Remember those that radical acts like parentheses. 64 plus 8, 72 divided by negative 2. Now, here's where we have to utilize what we did before. 72 we can simplify. And what we're going to do is we're going to utilize the same thing we did last time. Is we're going to utilize our perfect squares. Now, let me make sure my face isn't covering this up. Remember, our perfect squares are 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36. And I'm going to stop right there because 36 is a factor of 72. In fact, 72 is equal to 36 times 2. So what I'm going to do here is I'm going to replace 72 with 36 and 2 in this manner. I'm going to write x equals 8 plus or minus 36 times 2. Now, why are we doing this? We're doing this because we're hoping that if we simplify, it'll make things look a little bit simpler, I guess you could say. Sometimes it does, sometimes it doesn't, but it's a good skill to practice. So let's see. Now what we're going to do is, remember, we said that the square root of a times b is equal to the square root of a times the square root of b. That's a property that we know of. So we're going to split this up. 8 plus or minus the square root of 36 times the square root of 2. Now the nice thing about 36 is we know what the square root of 36 is. It's the number that when I square, I end up with 36. What is that number? Easy. It's 6. So I got x equals 8 plus or minus 6 root 2 divided by negative 2. Now at this point, what I'm going to do is I'm going to separate this into two pieces, right? So I'm going to separate this into, and it's because of this plus or minus. X equals 8 plus 6 root 2 over negative 2. And x equals 8 minus 6 root 2 divided by negative 2. Now, this next part might be a little bit confusing. It's something that we typically spend a little time going over, and it has to do with the properties of simplification. Oh my gosh, the order of operations. I'm sorry. And you remember what I said is that we need to simplify the entire numerator before we divide by the denominator. Well, that's not always true. There's a couple of exceptions, and this is going to be one of them. Now, what I'm going to do here is I have to look at these two numbers, 8 and 6. I don't care about the radical anymore. I'm just going to leave it as it is. It's going to stay as root 2 no matter what. And if I want to divide, I have to make sure that negative 2 divides 8 and divides 6. So I want to split those up into two parts. So what I'm going to do here is I'm going to rewrite this, and I'm going to write this as 8 divided by negative 2, because I'm dividing each piece by negative 2, plus 6 divided by negative 2, oops, root 2 divided by negative 2. So all I did is split this up into two parts here. Seems like we're splitting everything up into two parts in this case. But 8 divided by negative 2 is negative 4. Now, 6 divided by negative 2, we're looking at this piece right here. 6 divided by negative 2 is going to be negative 3. So this is minus 3 root 2. And this is as far as we get. We're done at that point. Okay, here's a recommendation for you. You just saw me do this one. You should pause the video and then go ahead and do the next one and see if you understood what I was talking about. But if you still don't get it, I'll show you the next one. X equals, again, we have two pieces, 8 and 6, and we're dividing them by this number that's down here. Okay, so what I'm going to do is I'm going to split it up into two parts. Minus 6 root 2 divided by negative 2. X equals, again, negative 4. 8 divided by negative 2. Now, 6 divided by negative 2 is going to be a negative 3. Now, when you subtract a negative, so I have a minus a negative, because this is negative 3. When you subtract a negative, you end up with a positive. So technically, it'd be like this, right? But this right here can be written instead and simplified to just plus 3 root 2. And you're done. That's as far as we get. Now, what are the actual solutions? Like if I had to estimate these, well, I'd have to actually plug this into a calculator so I can get a rough estimate of what the exact, what the exact answers, what the estimated solutions are to this quadratic. Now, I don't know if you can tell, but these are very similar. I got a negative 4 here and a negative 4 here. I have a square root of 2 here, and I have a square root of 2 here. I have a 3 here, and I have a 3 here. The only thing that's different is this minus and this plus. Okay, that's got a special name. It's called the conjugate, but you don't have to worry about that. And it turns out that they always happen in conjugates. Isn't that interesting? Probably not. All right, this video's taken long enough. I am so sorry. It's just a lot of information to send to you or to do in this video. But in any case, this is the last lesson. I think we have next week lessons, lesson A and lesson B next week, and then that's it, right? So make sure you guys are staying on top of your work. If you have any questions, email your teachers or ask questions in the comments for the YouTube video, and we'll try to get back to you as soon as we can. In any case, I'll see you guys next week.